All right. Hey, welcome everybody. It's Wednesday, March 2nd, 2022, in case you didn't know. There are a number of you on the call. If there are more of you on the call than we have names in the meeting minutes. So Mr. Chatterjee has shared the meeting minutes link in the chat. Do drop your name in if you're here. Otherwise, it doesn't count. Just kidding. As we get going, there's a few topics that we have, maybe a full agenda, we'll see. If you have topics, please drop them in. Just list them at the bottom. As we get rolling here, a couple of house cleaning items. One is that we record the meetings and post them on YouTube. There's a number of you that I know go back to review when you miss a meeting, and so that's great. You'll find them out there. Also, if you're new on the call, it's a good time to say hi and get to know everybody. Let everybody get a chance to get to know you. So is there anyone on the call who hasn't been on this call before? Anyone on the call that hasn't gotten to introduce themselves? It's always nice to get to know folks. For my part, I see all familiar names on the call. And so, good. Okay, last chance. Okay, good. All right, let's get started with our topics. So Manav is our lucky winner with today's first topic. And so just to add for context here, most of you are well aware of this because most of you are working toward this goal of releasing Meshery v060. We're currently in the release candidate phase for getting that release out the door. It seems perpetually just out of grasp. We're so close. In context of that, there's a whole roadmap that's been, the roadmap for .7 is outlined with some specifics. In a lighter way, the roadmap for v080, v090, and then 1.0, those are lightly outlined as well with the major goals in each. But this upcoming v070 release, it's outlined pretty well in two places. And so Manav, I apologize. I guess I'll preempt you with this because I think it's really helpful context for everyone, if I can. And this should be a great lead into what we're about to say. So Meshery v070 roadmap. A lot of you have seen this. A lot of you are working or will be working on these items. The roadmap is posted in 3 or 4 or 5 places. One of the places that it's posted in depth, one of those places is here. I'll grab the link. This went up, I think, late last year. Yeah. Just kind of planning ahead. Here's an item that Manav is going to talk about is on this roadmap, so I won't cover it, but I wanted to make sure that you all had context. The other piece of context that's can be helpful, and you'll probably see it from Manav here in a moment, is the architecture deck is kind of a centrally referenced deck that captures some of this, right? So spend a moment to just kind of review the top level goals of the next release. There are some names here that have been confirmed, and then some folks who've sort of either faded or maybe stepped back from those responsibilities. And so there's a few openings. So Rudraksh has stepped down from his maintainer role. Sumik is, near as I understand, still on the hook, or still desirous of working in this area, but we haven't heard from him for a month or so. And so that makes you wonder. Rodolfo has stepped down from his maintainer role as well. Michael is still on hiatus. Barak wrapped up a couple of internships and is taking on a different one. So he's not here either. So there's, and then Utkarsh, I don't know. He's trying to decide whether or not to continue maintaining or contributing. So there's a lot of change in the names that are here. And so you need to get some new names in there. Okay, with that, Manav, do you want to jump into this area? Give people an understanding where the project is headed, how they can volunteer, how they can contribute.
Yeah, so giving a glimpse of what it is, like a small implementation we have done in MeshMap. So if you see right now, these are the small graphs which are being rendered. These are dynamic according to the type we are selecting. So if we say this is a pod, the graphs are different, queries are different. Graphs are based on queries. So queries are specific to a type, which is the implementation of the custom part, which Lee already talked about. So if I say how they are, this is the pod level. There could be a container level. Containers would have different matrices, and each pod or container will have different sort of telemetries to be configured for. Now, how is it looks from the perspective of that of the code is basically if you see, this is an simple JSON array which is defined for each type. So it's totally dynamic. If we add one more type, it will be rendered accordingly. If I say now I want another matrix, say XYZ for some other title, I could just append it over here and it will automatically be fetched by GraphQL and displayed on the board which you are seeing earlier. So, and even it's dynamic on the basis of the kind. So if I say today I don't have something for namespaces, but tomorrow I have. So I will just append a key namespace and add the matrix which I want to display, which is a way of custom handling. Right now, it is present is in a form of a JSON blob, but we aim to convert it to a database format where these are stored in table. Now I will, like I've talked about it, so I will show you how it looks in architecture deck. So this is a glimpse of what is custom. I already talked about customs. Custom, the word custom means having customizable matrices, like customizable query according to the kind we want. Other term which comes is multiple telemetry providers. So right now we only focus on one provider, that is two providers, Prometheus and Grafana, and that too having a one-to-one relationship, that we have Prometheus, we have one Prometheus, we have Grafana, we have one Grafana. But this architecture which we are proposing will be having connections to multiple telemetry providers, not just like say there would be 3 Prometheus, 4 Prometheus, 5 Prometheus, any number of Prometheus, any number of Grafana, which will be configured according to their pan. Now I talked about database. So a glimpse looks like this. Like this is the current architecture, which is just one-to-one relationships going on. But with the database prospectus, it will look dynamic. And whenever say we add a new entry in the database, it will be fetched according to its parameters and rendered on the, like we saw the panel in Meshery, it will be on the mattress section. So that's a brief about custom matrices. But the architecture is not yet complete. It has different openings and it has different parts which could be improved upon. The table itself could be improved upon. So That's all. And I like to you guys to work and contribute and write comments to it so that we could work and enhance this, and at an instance we could have it fully working. Yes, that's all from my side. Any questions I could answer?
Yep. So like a lot of presentations, there's kind of two reasons why Manav brought this up. One is to demo progress on an aspect of Meshery. The other reason he brought it up is to, well, encourage everyone to participate, let everybody know what's going on, give you an opportunity to jump in, to collaborate. So yep, if you're into React, it's a good chance to collaborate. If you're into Golang, a good chance to collaborate. If you know some GraphQL, that's also involved. If you know PromQL, or if you're familiar with Prometheus, sort of between those four technologies, and if you can put up with Manav, then just kidding. Then like reach out to him and inquire more about what's going on there, where you can jump in. Part of it too is a bit of database design for distinguishing between kind of out of the box or static metrics versus custom metrics that a user defines. There'll be, like Manav was saying, there'll be certain areas that are customizable within Meshery's UI to allow an individual user to choose which metrics they want charted, potentially what type of chart they want. The goal here is to augment and embrace any efforts that users have given to use of Prometheus and or use of Grafana. So one of the things that Meshery does is, well, it will connect to your Grafana, it will connect to your Prometheus instances, it'll connect to your Grafana instances. And right now we're only talking about metrics, right? Because there's other types of telemetry. But for metrics, Prometheus and Grafana are kind of the two integrations of focus. And so Meshery will not only speak to Prometheus. Today, it only wants to talk to like one at a time. Tomorrow, in this next release, it needs to talk to multiple at a time. It needs to understand which Prometheus to get what metrics, and then where to show those metrics in which part of the UI. It also, today, Meshery will connect to your Grafana instances and ingest any Grafana boards that you might already have defined, which is to say that if those Grafana boards have a definition of different panels, boards and panels are Grafana nomenclature for charts and metrics. Meshery will ingest those. So Meshery embraces the investment that people already have in Grafana. Beyond that, what Manav is also saying is that it may be the case that people want to see specific metrics charted in Meshery's UI or tracked. And so this will be a mechanism for doing that. As you look forward to like the .8 or .9 release or the 1.0 release, you'll find evidence in the roadmap of other related integrations that would build either on top of this functionality or beside it. So other things that would sit beside this is support for telemetry types other than metrics. So most notably logs and traces. And then functionality to be built kind of on top of this might be integrations with eventing systems or alerting systems. So to the extent that a policy engine is built into Meshery and a workflow engine is built into Meshery, those policies and those workflows that the policies trigger might be based on metrics, watching those metrics, and then taking action based on a threshold being crossed, based on an anomaly being detected, based on something. So kind of a lengthy roadmap in and around telemetry. And so Manav is trying to give forethought as to how to, establish an architecture in which that, that vision can be built on. So. Thoughts, questions before we move on? Alrighty, Manav, thanks for that. It's nice to see some progress as well in terms of additional support for PromQL in MeshMap. It's good. Rudraj, I think you're up next.
Yeah, hi. Can I share the screen?
Oh yeah, please, always.
Okay, so yeah, this is just follow up on the issues that we were having with mesheryctl system stop command. And I had a talk with you and Piyush, and we decided that we came to the conclusion that the default behavior of stop should be what an average Meshery user would expect from system stop, which is to get rid of all Meshery resources. So because of that, earlier what was happening was, if you can see my screen, just switch out of yeah. Okay, so if I just say system stop, and if let's say some resource is not running, or it's failed to come up. For example, in this case, I intentionally deleted the custom resource, so it just errors out. It doesn't stop because it says that the server could not find the CR. So this is solved with the force flag, but the problem with the force flag is that it's not like an average user should not have to put up a force just to have expected behavior. So what I was thinking about, and what like PU suggested also, was we make the behavior of the force flag as the default behavior. So basically, in that we won't be using Helm to uninstall the resources. Instead, we'll be directly using the Kubernetes client to manually delete all the resources. And yeah, so that was the plan. And also another thing I was thinking about is to remove the check. Like at the moment, stop, when you call system stop, it does a check on are Meshery components running. So the problem with this check is it only checks for deployments, and I feel like this check is not very necessary. If we're going with the model that we just try to delete everything, and if it doesn't exist, we just ignore it. So if that's the case, then we don't need to check if Meshery is running, because if it's not running, we'll just go through, we'll just find nothing, and we'll just move on. So these were the two things that I wanted thoughts and opinions on. Yeah. So yep, I guess that's it.
I'd love to offer up some thoughts and opinions. I just want to give room for others that might have. Raja, and from my perspective, I think you captured it really well, which is a little display of force, maybe by default, is kind of what we want. It's kind of the behavior that users want from mesheryctl. And that is like, if you execute a command that says start Meshery, then by God, do that, start it, and stop letting Helm get in the way. Helm being all sensitive about stepping on itself on a prior deployment or what have you, is like, no, just start Meshery. Like if there's already components of Meshery started, good, like maybe even overwrite them and upgrade them just in case, just in case you stay in sync. It would be the oddity that someone would start Meshery, there are existing components at an older version, and someone actually desired that those existing older components didn't get upgraded, up leveled at the same, when you were to reinitialize Meshery. There can be a flag for that oddity or for that like 20% use case. But yeah, and I also think that you also, and we kind of talked about this, and so it's a little bit of a repeat just for everybody else to hopefully start to mentally align with some of the philosophies. And one of those that you just pointed out is, well, it's easy for most of us nerds or most of us engineers to like want to engineer something. And so we want to make smart systems that hopefully delight people. The risk around delightful software is that usually things that delight people are things that are somewhat opinionated, and they just kind of, they're intuitive. They sort of get the, not only do they do what you were expecting them to do, so they're intuitive, but they also take it like one step further, and therein lies the delightful part. And it's really nice. People want to come back, users want to come back and use that type of software. The risk in imbuing opinion and trying to intuit what people desire is that you try to make the software too smart. And that's actually in part what you were just pointing out, which is like, if I forget what, if someone was saying, stop Meshery CTL system stop. And as we're doing it, we check to see if Meshery is running. It's like, what does it matter? Just stop it. And if it's already stopped, yeah, great. So let's stop tripping over ourselves. Let's stop trying to be smart. And yeah. So
yeah, that also comes with its own problems, because it only checks for development, so deployment. So if you have, let's say, a service running and all the deployments are gone, but the service is running, so Meshery will be like, yeah, Meshery is not running, so I'll not stop anything.
Is this, most of you are familiar with this. There's this nice KISS principle. And it's a healthy reminder that we generally try kind of get in our own way. Keeping it simple is probably the right thing. Anybody else want to wax some poetry on what we just said? Anybody else have an opinion on? Yeah, Helm has been, so we're using, Meshery CTL under the hood and Meshery Server under the hood are using Helm foremost as the provisioning utility or provisioning framework. And over time, since its genesis, Meshery has used a number of different mechanisms. We recently, with Husseina's help and others, and help from other people, we've gotten off of use of Kubernetes manifests, hoping to find economies of scope by using just Helm as the installer, and therefore less code, fewer bugs. And thus far, Helm has been a pain in the rump in terms of like doing what you ask it to do, which is just install something or uninstall something. They're good. I've got my fingers crossed. Like, how far out are we, Root Rush, on landing that forceful feature?
Yeah, so I think it's kind of straightforward. It'll be done very, very quickly. At least the stop part, the start, we'll still have to kind of think, because we start stop. We have an alternative to just hammer and shut down components, but start we now rely heavily on Helm.
So for stopping, you'll bring out the hammer, and then but for starting,
yeah.
Say it real quick again. Like what are the open considerations that need thought?
We might have to know, like we used, I think Hussein asked something in chat. So we use Helm for install and update, and uninstall code will be cleaned up from MeshKit repo. So the like the uninstall code will be, I'm not sure what you mean by cleaned up, but the uninstall part will just call the Kubernetes client, and it'll just tell tell it to like delete components. But yeah, so the thing with start is like we need earlier we were, as you said, we were using Kubernetes manifests. So that's another way that we can do. But yeah, so right now we're just using the Helm package and the Helm charts. So yeah, that'll be. I'm not very sure about start what we'll do, but stop is pretty straightforward.
And I think Hussein, and correct me if this isn't what you're asking, but in part you're clarifying that, like, hey, are we consolidating logic that interfaces with Helm? Is that logic all being consolidated to MeshKit? I think that's what you're asking. Both for install and uninstall.
Yeah. Yeah, for uninstall, yeah, I think it'll be the same. Yeah, so we've been used it's basically just exactly what ForceFlank does at the moment. So yeah.
Feedback for Rudraj. Questions. One of the things that contributors will run into is that there's a couple of mechanisms by which people would commonly start Meshery or deploy some of its components. Most commonly for users, that's mesheryctl system start. Sometimes it's by running the bash script, like curling and running the bash script to start Meshery. Internal to that bash script, it calls mesheryctl system start. So it's the same kind of starting point to deploy components like Meshery operator. And that's the Meshery operator and some of the Kubernetes cluster roles and cluster role bindings have been part of the challenge with use of Helm. For many of you that are contributing, you'll also note that when you make Meshery, build it, and you end up pointing at your Kubernetes cluster, when Meshery server connects to Kubernetes, it will attempt to, and most commonly be successful in deploying Meshery operator. It will also deploy a couple of cluster roles and cluster role bindings. And so there's, at least in my mind, sort of two primary starting points for where it is that Meshery might have been installed. And so Rudraj, as you work through forcing start and forcing stop, it's good to confirm from both perspectives. And that's actually in part why I think the fact that we have two different starting points is in part why trying to be too smart about checking for whether or not Meshery is running becomes an issue. So.
And yeah, to answer Mario's question in the chat, I feel like, yeah, we're right, even at the moment we're doing that, and I think that should be done is to remove the deployments which are made by Meshery, like app pattern and filter, while stopping. So basically stopping will remove everything unless you give it the keep namespace feature. It will also remove the namespace.
Good. Okay. Is Augustus here by chance? I don't know that he's on. Okay. Ashish, if you're on, do you mind calling for volunteers, sort of explaining the challenge that we currently face with respect to multi-cluster support in the UIs?
Yeah, sure. Am I audible?
You are. Your voice is a little low, but you are.
Okay. So recently we added a support for multi-cluster, multi-context in Meshery. And from backend, we have, at least for now, as we think, we have solved most of the bugs around it. More bugs will be there when actually basically that API would be consumed by the UI, be it Meshery UI or Meshery CTL, and they are not consuming it right now. By consuming, I mean that at Meshery server in the middleware, we actually are currently grabbing all the context. So, okay, so let me give a little bit of context around this. No pun intended. So currently, if you basically make an operation, basically you start an operation, you make an operation, be it like install a service mesh or something like that. It happens on a single context, that is your current context inside of your kube config as of now. So you have one context that is your current context inside of your kube config, and on that cluster, that particular operation is applied. That operation can be anything that can, if you go into that lifecycle page, you'll find that there are multiple operations that you can actually apply in any of a given service mesh. Currently, before this multi-context PR, that thing was limited to single cluster. But as you can see on the dashboard, as Lee was showing, he has only one cluster right now, one single context inside of his kube config, the Docker desktop one. So that's why we only see that. Currently, that particular thing in the navbar is it's only for show. Basically, it does not do anything. So the call for volunteers is to make it do something. And what do I mean by make it do something? Basically, when we click on any, let's say there are 5 contexts in that particular drop down, and someone clicks selects 4 of them. So we need to persist, first of all, persist that onto the front end, that these are selected contexts. The next step is that after selecting those, if any operation is applied, like install a service mesh, or basically a pattern file is deployed in meshops v2, or basically any operation is performed, we need to do that on all of the clusters. And how we would do that from the UI part is by providing the context IDs of all the selected contexts in the query parameter. What that makes, basically when you do that, when you provide context ID of all the connected context in the query parameter, at the backend we actually extract that and provide that to all of the handlers, and they can handle it in their own way. So for example, when you install, let's say, Nginx service mesh, and you have selected 3 contexts, and when you'll click on deploy, what would happen is that you'll have the similar installation across all of your 3 clusters, or all of your 4 clusters, or any number of clusters that you have right now. So the current task is that both in Meshery CTL as well as Meshery UI, because a lot of times we forget that we have Meshery CTL as well, and it's important to take that along. So people who want to contribute in Go, they can go over Meshery CTL. People who want to contribute in React, they can go over Meshery UI. Basically, we want to be able to, any request that is concerned with anything related to Kubernetes, whether installing something in the cluster or anything, you need to get that context, and the endpoint is /API/Kubernetes/contexts. There you'll have the all of the available context from there. Basically, after you persist the context IDs, you can provide that into the query parameter, and backend will handle it. All you have to do is persist that for the Meshery UI part, persist those contexts somewhere in React, or in Redux will persist that into our state. So persist that, and then on every API call after that, basically send those into the query parameter. From Meshery CTL, do the same exact thing. I don't know how we would approach this in Meshery CTL. A little bit of thought would be required. Like we can maybe provide a flag or something, basically to tell the user that in which particular context or in which particular cluster they're actually applying that operation. For example, right now, if you just say Meshery CTL pattern apply, or Meshery CTL something system something, then that would only take place in your current context. We need to take care of that too. So maybe a flag would be a nice thing to have. So if anyone who's looking to contribute in CLI, you can add a flag, and what that flag will potentially do is that it would okay, so what that flag should do, I think we can make it like a little bit user interactive something. Maybe if they don't specify a context, we provide, when they do Meshery CTL pattern apply something, and when they click enter, we show them all of the basically available context on which they can apply it to, just like in UI we have. So this, from there they can select it. I was just going over the possible ways. So basically the point is that in UI as well as Meshery CTL, we need to use these context IDs and pass them into query parameters, so that basically we are making use of this new feature that we have. So yeah, that was it.
Who got lost on that, or who didn't get lost and has kind of suggestions about where to go next? There are a couple of, so as we look toward v0.7, there are a couple of design specs to review and give further consideration to. So to fully wrap up kind of support for multiple clusters, there are some enhancements needed to, a couple of enhancements needed to Meshery CLI as a client. There are a few enhancements maybe wanted, but only a few needed. And then there are a number of enhancements needed in Meshery's UI to ensure that when someone is looking at, to ensure that, well, I won't repeat what all of Ashish just said. He just kind of described much of the need from this client's perspective, but it's really, it's both clients, like he had said, Meshery CLI and Meshery UI, that need to account for a multi-cluster / multi-context experience. Much of the inner workings of Meshery server, Mesh sync, the Meshery operators, there's a lot of support for multiple clusters today. But it's incomplete when you look at the clients, when you look at Meshery UI and Meshery CLI. So if you're in the community or have kind of filled in your member form and you've got access to some of the community resources, I'll drop a link to a couple of different documents. I think we can delete this doc. Good. I think this is all mostly been moved. These are just kind of notes. We'll get a link to, I believe, this central document. Anyway, you'll find this as a topic inside of the community drive. Questions, comments from folks? Like, again, like this is, both kind of a review of recent enhancements in Meshery and a call for participation. So, in the two clients, Meshery CLI, that's Golang. In the other client, Meshery UI, it's React and GraphQL. It's a bit of a REST, GraphQL client, REST client. Part of the goal for the next release of Meshery is to really get the UI off of the REST API and very much so onto more of the GraphQL API. So we get a link. There's Meshery CTL. Comments, questions?
Okay, so the design spec for Meshery CTL has been written already, and I have made some comments over there. It's a request for you guys to go over there and check what those comments are, and so that we can progress ahead and work on what we actually want to make, make the CLI work, how it will work or not. So it has what should I say, a proposal for how mesh config can work with multiple Kubernetes having their names or maybe their kubeconfig paths. But I disagree with that kind of proposal for mesh config. And I have raised comments in this documentation document, why this is a bad idea. So check that out and tell me what your thoughts are on this.
Yeah, Piyush, I want to make sure that I'm looking in the right place. So there's many months ago, there was this design spec that was created kind of in early support for Meshery CTL and how it might, how it might support.
I think I shared different document. I'll share the link again.
Okay. And so here you go. Yeah, here's your comments. I think you put your comments and your thoughts into the correct doc. I think we're trying to consolidate kind of all of the multi-cluster, multi-context thoughts into this doc.
Yeah, so I have like this is here. But
perfect. This is great. Yeah. Yeah, what an opportunity for people to jump in and consider this. This area. Actually, I'm going to make a statement, and I'd love to hear if people think potentially differently. One of the, well, not singularly novel, but one of the more novel functionalities that users would come to enjoy from Meshery, from a management plane, is functionality around multi-cluster support. And then all, just in general about managing multiple Kubernetes clusters, but also about managing service mesh deployments that span multiple clusters. And there's a number of, the networking gets fun for those service mesh deployments. Meshery will need to be aware of some of what that networking is. You'll need to help configure those service meshes to configure those service meshes to do different style deployments, because there's different ways of interconnecting clusters. So this will be a juicy area.
Yeah, are there any meshes that have a fully fleshed out multi-cluster approach? I know that Solo, I believe, is working on multi-cluster mesh, and maybe a few others, but are any of them actually to the point of being ready for production use?
Yeah, and good question, Jared. Which one did you just mention that's working on stuff?
I think Solo.io. I thought they were working on something like that.
Oh, yeah. I mean, so I don't look at Solo stuff much, but there's Glue Mesh is kind of a competitive project to Meshery, at least right now. It's not intended to be, but they really only support Istio anymore. There's some claim for supporting open service mesh, at least of what I can see in the code. Like there's some claim for supporting open service mesh and maybe app mesh, but probably pretty nascent. Anymore, they have a product offering that is a distribution of Istio, and they, at least last year at their last SoloCon, badmouthed is probably the most accurate way of saying it. All of the other meshes other than Istio, and basically said it's an Istio only world, and they've rebased their product on Istio, and they're adding value on top. And I added a lot of comments just then on things that I've seen in the past. I haven't seen any of the enterprise offering or the value that they add on top, and I'm sure it's great. I'm sure it's quite helpful. No doubt they've got solutions around homogeneous, like the Istio, multi-cluster Istio deployments. No doubt they've got that covered. Istio itself has a few different styles of like multi-cluster deployments, or a few different configurations that they support of deploying. And yep, people are running multi-cluster Istio deployments in prod. Some of the devil is in the details in terms of like, what do you mean by multi-cluster? Is that multi-control plane? Like single central control plane, some control plane components spread out across clusters. There's a couple of different deployment models, but at least as I've been able to keep up, Istio has a couple of different answers here that have been around for some while. some of how that is implemented has changed over time, for sure. Over the last 2 years, like changed a fair bit for the better. And then, like I don't know, I'd be surprised if Kong/Kuma didn't have, like, it may not, Kuma itself may not support it, but maybe Kong does. I don't know. Console, like, they definitely support federation as an enterprise feature. They definitely do. So
Okay. The reason I was asking is I was wondering if there might be a benefit in separating the multi-cluster topic here into Meshery in the idea of using contexts to switch between completely separate clusters. So you have a cluster in EKS, one in AKS, one in GKE, whatever, and they're each their own thing, and you can just point Meshery, say, hey, use this context or this context. You can with kubectl. I know you say don't cuddle your infrastructure, but I'm going to keep doing it. kubectl, kubectl, whatever you want to call it. So that seems like a very addressable discussion there. Then the other topic would be the multi-cluster service meshes. And I was wondering if it might be helpful to split that out into separate efforts. And if it would be easier to, does that make sense?
Yeah. Let me capture. Let me make sure I capture the first one, and then I'll regurgitate the second one, because I think I got what you'd said on the first one, at least for my part, and Ashish and others chime in. Jared, what you had said is like that totally makes sense. Which is, I'll kind of regurgitate it for the rest of us as well, in context of kind of what you see in the UI is like sort of leaning into the UI, kind of leans in, at least in my mind, it leans into what Jared is saying, which is like, actually, if for a moment to just reduce complexity of this conversation, this topic, if we set aside service meshes for a minute and just say, hey, as a user, I've got a handful of clusters, Kubernetes clusters. Maybe they're running a mesh. Maybe they're running 20 meshes. Who knows? And there's some operations that I'd like to perform against, or some maybe metrics that I'd like to look at against just that cluster over there. And then I'd like to maybe update that cluster or perform an operation against just that one. And then I'd like to kind of quickly switch contexts and go cuddle some other infrastructure over here. And so, yeah, this switcher, if I characterize that correctly, Jared, like this switcher is extremely well aligned with your sentiment.
Yeah, and hopefully I understood the original topic we were going on here. It just looked like there was a bit of two separate topics going on at once there. Let's see, multi-cluster items, and I wasn't sure if that was in regards to how Meshery is handling multi-cluster, or if that's more about the underlying service mesh handling multi-cluster with all the networking things that go with that. Yeah,
you're right. You're right. On your second topic, like it is a kind of a massive topic, and is something to be pulled out and considered unto its own, which is, yeah, for each of the service meshes, that they each have their own, well, they each do or don't have their own configurations in which, deployment configurations in which they support a mesh, one of their meshes spanning multiple clusters, or like whatever those configurations are. They each have their own kind of current approach to running a mesh in the face of multiple clusters, or running multiple instances of the same mesh in the face of multiple clusters, or maybe running multiple instances of the same mesh in the same cluster. Like all of them to varying degrees have addressed those kind of those set of topics. And yeah, you're right that actually as I was speaking a moment ago, I was getting into that topic very much to say, like, hey, it's one thing to kind of, I think it's a simpler consideration to make that, like, as a management plane that you might speak to, you might invoke operations and sort of look at one Kubernetes cluster at a time. And maybe that Kubernetes cluster is running one mesh and it only spans that cluster. Maybe that mesh spans multiple. And so like after you've kind of solved just the simpler use case around just Kubernetes itself and multi-context, multi-cluster, concerns, then like a next significant, and to Jared's point, like separate set of concerns and topics to chew through is like, okay, well, so fine, you've got, as a project, you've got great support for multiple Kubernetes clusters, and then in this environment, maybe we've got 4 clusters deployed, 4 Kubernetes clusters, and a deployment of a mesh that actually, spans and runs workloads across all 4. What does that look like in the UI, and how do you let someone know that, like, what's the construct for representing that? Because today this doesn't provide you that info. And to the extent that not only is Meshery doing that maybe for like an Nginx service mesh deployment that's across clusters, that then also it's doing that for console or for some, like, it gets fairly complex in terms of both supporting those environments, but then also providing people a user experience around that. And so what is that? So yeah, I'm in vehement agreement with what you'd said about multi-cluster service mesh deployments, their configurations, and that being its own, it's a thread. I think it's something that we can start iterating on now. We can, we'll want to get, as we put thoughts on paper on this subject, we'll want to be hardening and completing the underlying support for just Kubernetes contexts themselves, have a solid framework for then but it doesn't, for then moving into this next topic. And it doesn't hurt to start talking about the topic, because it may be that certain constructs, or like spanning an instance of a thing, a service mesh, spanning not all of your clusters under management, but maybe only part of them. What does that look like? And how would that affect the type of support that you're providing for Kubernetes support? So, which is to say, one of the concepts that we talked about, and so maybe Jared, this might fall in line with your thinking, is that let's say that, let's say that you're in an environment and you've got 30 clusters. Like in this day and age, I'm not sure that that's even a very large thing. Maybe you're letting all of your developers individually connect up their clusters to the same piece of management software. And so, if you got 50 engineers, they've got their 50 clusters, then you've got, 10 in prod and 10 in QA, anyway, you can end up with a lot of clusters. And so, hey, at some point the UI could become unwieldy. Maybe you have a collection of clusters that you'd like to group together, and that group is in a specific geographic whether you want to carve it up by region or by purpose, like that's prod, or this is a dedicated group of clusters for an organization or for a customer, or so this concept of environments, like there may be the need for another construct, another concept, whether that's cluster groups or environments. Is that in part where you were going, Jared?
Well, that's I was going a bit further than I was thinking, but that's some great observations. what I was thinking, I guess, is more of a project perspective and making sure we can walk before we can run.
Okay. Oh, yeah.
Because I'm sure this will be a fair amount of work. And the fundamentals would be making sure that Meshery can handle the multi-cluster use case. And then I think the next step would be, all right, so we know that we can handle multi-cluster. All right, so now how are we going to integrate with service meshes who are communicating across multiple clusters and tie into that? And so I was thinking of using the Meshery multi-cluster context as kind of the first stepping stone there, rather than combining them. So more of just how we're approaching the development side of things and what gets done first, I guess. Maybe that goes more into a bit of a roadmap topic.
Yeah. Nice. Jared, this is, thanks for bringing this up. I mean, this is, pour those thoughts into here, if you would, or like, and you're right about walking before we fly. There's some running in between we fly, which is, there's some advanced, like this is some fairly advanced and somewhat complex stuff. And part of the challenge with this body of discussion is not just that it's somewhat, sophisticated in nature, but it's also that it can be an area of volatility for the meshes themselves, as some of them are evolving in terms of how they do like their own federation. Yeah, Jared, I can only encourage you to make a mess of things like with those thoughts and yeah, whether they're design concept in thinking, or if they're just sort of procedural in, hey, prioritizing what we should collectively do first, like all of that is welcome. Yeah, please jump in.
I do pretty good at making a mess of things, so this is good.
Well, we're right at time. Did we miss anybody today? We miss any topics that people had?
I actually had something quick, but I see that there's another topic there that somebody got in before me, so you have to let them go.
Yeah, I don't think Navendu isn't on, and so we're at the end. If you want to hit your topic real quick.
Okay. It's mostly just a heads up regarding some changes in MeshKit and Meshery Adapter library. I've been working on updating those to the latest Golang version, and there has been some had to make some other major changes as far as some of the references, because various libraries have made breaking changes. For instance, some of the logger references in MeshKit I had to update those, and then in Meshery Adapter library to make some changes to the open tracing references. Some of the structs and things have been renamed or removed altogether. The project was restructured, things like that. And so I was hoping to get those merged in, but I'm afraid that there might be some unforeseen consequences part of that. I'm not sure how all the dependencies work out. When I first, I started out, I was planning to update Nginx service mesh adapter, and then I ran into a dependency failure on Meshery Adapter library. So I went to update that, and then that failed because of MeshKit. So it's this long chain of dependencies. So I've been trying to work through that, but just wanted to give a heads up if those do get merged. There's keep an eye out in case anything else starts failing. And so we can try and get those updated as quickly as possible. Or Lee, I don't know if you have a process for this sort of thing.
Yeah, it is. It's about what you just said, which is trying to make them happen as quickly as possible. Like sort of enlist, or it's actually exactly what you're doing, which is as changes are merged, an edge release is immediately made on build. But then as you go to release any of the adapters, in this case, that will produce a stable release of the adapter. And so propagating that change across the rest of the repos is like Ashish Tiwari is probably is one of your brothers in arms here, or like your partner in crime, or however you want to think of it. But it's to help like both potentially get you empowered with some permissions to like move briskly across, but also to help be QA for you, or provide feedback on what those, like what those breaking changes are impacting. It's about time for like a minor bump in Meshery's overall release anyway. Like, I don't know how many more release candidates we can do, the numbers allow. And I say that jokingly, actually. We're ready for another Meshery server release. And so understanding that Meshery server also leverages MeshKit, it may be, and they're breaking changes, we may be forced to make that release, and that's fine. Like, it's time. So we shouldn't let that happen.
I wouldn't necessarily say this is urgent. If you want to wait till after the .6 release, to avoid muddying the waters further,
Right.
That's fine as well.
Yeah, if we can. Okay. Is it possible to, like, for us to get the P, well, I was going to say get the PRs queued up. I guess the problem becomes if you don't make a release of MeshKit, or we should be able to, I don't know, we're this close to making the .6 release. If we do merge changes in MeshKit and the adapter library, that'll position us for a quick update to each of the adapters. And with any luck, by that time, the .6 release would be ready to go out anyway. So it's not like we would have to.
MeshKit has already been merged. That update has been merged. And so if there's another release made for it, those changes will get picked up. If you want, we could probably revert those changes. If you didn't want to risk getting them in the .6 RC.
Yeah, no, nope. For the most, yeah, nope. Because what would happen then is like, earlier the better. Honestly, because what will happen is like if we go make a marketing splash around the fact that there's been a release, if we then say, okay, good, the release is done, let's go ahead and like start merging like it wouldn't be too long before we would make kind of a stable release of a 6.1, and then we would be facing the same potential, risks. So we're not risk averse, I guess, is what I'm trying to say.
Okay. Ashish, do you think that we could work together after this meeting to get those merged in, get the MeshKit release, and then I'll have to update Meshery adapter to pull in that release, and then
Sure.
Okay. Well, we can sync up on Slack after this. Cool. Thank you.
That's great. All right, we're a bit over time. It was very nice to see you all. And it's nice to hear some meshy jokes too. So good. Okay, we'll catch you all in either in Slack or Raj is alluding to some things that we'll talk about, I think, on Friday for preparing for both She Code Africa and Open Force. So talk to you all very soon. Nice to see you.
Cheers.
Bye.
Bye.